Welcome everybody to the first part of many parts related to the brain and how it works. This is a series for my clients that worked with for a while and allows you to kind of take a deeper dive into the neuroanatomy of the brain, the neurophysiology. We'll also, during the series, address a lot of things like heart rate variability, breathing, sleep, hormones, visual processing speed, and different forms of assessment as we go through. But for today, kind of kick off to the series, we're going to just talk some basics about how the brain functions and what is it that we need to focus on in order to optimize it right out of the chute. Because you're probably wondering, I want to watch multiple parts, but I need to know right now, what do I need to do to fix my sleep? What do I need to do to work on my anxiety or my ADHD? So this is the base, and I recommend that of all the different series that you're going to see, this is the one that you probably want to come back to periodically and rewatch. These are going to be about 20 minutes long, and this is one that maybe even 2 months later you come back and watch it, because it's these basic principles in here that are crucial to your understanding of what we're doing in treatment, what we're doing in assessment, and how we're working with the brain. So first of all, we got ourselves a brain today. Okay, always keep an extra just in case I need it. No, but this is the actual size of the brain. It's 3.5 pounds. It's divided into two parts, two halves. There's a cord, this kind of white area, that connects the two halves, called the corpus callosum. Today's not a day that we're going to spend a lot of time getting into neuroanatomy, but there's some really cool things in understanding the brain, areas like the hippocampus, which store memories, understanding the temporal lobe, and also the frontal lobe, which has to do with executive functioning and impulse control. All these things that impact our behavioral and physiological functioning always start with the brain, okay? And something you're gonna hear me say over and over again is, when we're talking about optimizing the brain and addressing specific behaviors, we can't just look at behaviors. We have to look at the brain, which is driving those behaviors. And unfortunately, many times we go into a doctor's office, all we're doing is getting a checklist of behaviors. You're rattling through those, sometimes in under 10 minutes, and then you're walking out with some chemical that's going to impact the brain. Well, you only get one of these guys. So we want to make sure that we know what it is we're addressing, because you can have 100 people come in with a sleep problem, and there can be 100 different reasons related to the brain or other physiological concerns like hormones that is impacting that sleep. And one medicine, one size does not fit all. Every brain is unique, and that's very important, okay? And it's also very important to know that in that uniqueness, when we look at the grand scope of things, the more you analyze the brain, the more you realize that there are no two brains that are alike. We're talking from the beginning of time till the end of time. Every brain is unique, okay? And you're not just a diagnosis. You're more than that, okay? You are very unique. There's never been anyone like you ever created. And we need to understand that if we're going to optimize the brain's functioning, the physiological, the emotional things related to the brain. And, should you be like many of the athletes I work with that want to go to another level, or an executive that wants to take their focus to another level, their sleep, their creativity, you got to understand this in order to move forward with treatment. Many times people start a journey and they don't even have a roadmap because they haven't done a good assessment. And we want to help you create that roadmap. So there's some basic principles we need to understand about that. A couple other things before we kind of get into those principles is, there's really nothing like this, the complexity and the wonder that exists in the brain. There's nothing else like it in the entire universe. It's absolutely amazing. Within here, we have neurons, which you've probably heard of those things, or neurotransmitters that are the chemicals that send messages between the neurons, because they don't really touch each other. There's like a little gap called a synaptic cleft that the chemicals send little signals to each other. And all of these neurons have little branches to them. They kind of look like a branch with other branches coming off of them. And they form all kinds of neuronal connections. And it's estimated that there are more neuronal connections in this 3.5-pound organ than there are stars in the entire universe. I mean, just think about that for a second. The connections in your brain, there's more of them than there are total stars in the universe. They estimate that it's a quadrillion. That's 1 with 20 zeros after it. I mean, that's just crazy to think about it. You know, sometimes I have days where I feel like I only got 3 connections going, but it's never like that. There's some really complex things that the brain's doing. And many times we just focus on the conscious things, the things we feel on the surface. We've spent a lot of attention on that. We don't realize what the brain's doing 24/7 from the time we're born until the time we die. Just one illustration on that would be, think of the number 98.6, okay? What is that? Yes, it's a radio station dial, but it's not that. I'm referring to body temperature. 98.6 is our body temperature that we maintain from the time we're an infant until the time we die, 24 hours a day, 7 days a week. Our entire life, our brain maintains our body temperature at 98. It's just crazy. It's mind-blowing to think about that, right? No matter where I am, I could be in Alaska or the Caribbean. It could be 2 in the morning. It could be 2 in the afternoon. It could be the winter. It could be the summer. Whatever it is, the brain is figuring out exactly what's going on in the environment and how to control this at all times. I mean, it's just crazy. And it's doing that with so many different systems in our body that we don't really step back and think about it. I always tell people, even in the worst situation, I've done this for 25 years. I've worked in some significant psychiatric facilities, been the division chief of psychology at a very large children's hospital. I've seen over 50,000 brains. And when we look at the complexity of what the brain can do in the most difficult situation, it's still the most amazing thing that you've ever seen in how it manages the body and our thoughts and our emotions. And as a human, we have the luxury of a brain that has a huge frontal lobe that lets us do some really amazing things, which we'll get into. So let's take the last 10 minutes or so, and let's just dive into a few basic principles that we want to look at in regards to the brain. It's very important that we understand that the brain, you've got the neurotransmitters, those are the different chemicals, you got the neurons, you got the axons, you got all these different things. Those are like wiring, and then the signals are transferred through neurochemicals. But what is all this for? Well, all of this stuff that is in the brain, all these wires and chemicals, is to manage or work with electricity. The brain is an organ that's not very different from other electrical devices you might interact with all the time. It requires electrical current. And in some upcoming lectures, you'll actually see the electrical current in the brain. We're actually going to do a live presentation of and understand how we can dissect that electrical current and learn about different aspects of the brain. And so the first question that should come to your mind is, where is all this electricity coming from? Like, I need it 24 hours a day, 7 days a week. This isn't a trick question, but what happens if you don't have electrical current going to your brain? Well, the brain needs it 24/7. We die, we flatline, and we don't want that to happen. So we're constantly making electrical current. And the question is like, how are we doing this? How are we making this electrical current? I get it from my phone, right? Like, I get how that works. I look at the battery, I'm at 44%, okay? Halfway through the day, I gotta get to a cord sometime today, plug this thing in and get some electricity. And that electricity, if I tracked it back, is going to go to some type of power plant. I know that's where it's gonna go through an electrical grid system, it's gonna come to my house, it's gonna come to my office, whatever it's gonna do, and then I'm gonna plug in and I'm gonna get my battery charged, right? And then this is gonna carry it through battery storage, but I gotta plug it in at night, right? I don't know about you, but I don't remember last time I needed to plug myself into an outlet, right? I don't rely on an electrical grid system. I don't need a power plant because I make it all on my own. And there are some very important things that contribute to making that. And let's just think about a couple of them, okay? Um, one of the first things that's pretty obvious, right, is I need food, right? Gotta have food. Super important, okay? But when you think about it, I can go a little ways without food, right? I don't have to have it every second of the day. I can even go days and weeks without food, and I'm still gonna make this kind of electrical current that keeps the brain going. I'm not gonna skip a beat, okay, if I miss a meal, right? So I wouldn't put food as my number one thing, okay? It's important. And also underneath food, when we're thinking about food, a subset is what is the quality of the food? Okay. Okay. While I don't need it constantly, the whole reason we talk about nutrition is because that is a power source for making electrical current, just like water might be for this plant, or I don't know what it is, a coal plant, whatever. But the quality of the resource that you're burning impacts the quality of the signal, right? Like I can make electricity off of a Big Mac, but it's not the same as a meal that is well balanced with proteins and fats and carbohydrates allocated accordingly, with more things that are organic and clean, you know, not full of all antibiotics and all that kind of stuff. So quality is super important. And many times if the quality is bad, our body still seeks more food to try to get what it needs to make good electrical current. And many times that's related to overeating, okay? A second thing that we want to look at, and I'm not going to say that, I would say that this is important, but it wouldn't be at the top of my list, and that would be water, okay? We don't need it every second, but we can only go a few days without water. Number two, I'm going to put sleep, okay? So we got sleep, water, food, okay? Sleep, people miss this all the time. I've done a ton of work in the sports world. I've tested over 600-700 athletes in looking at hormones and sleep studies and EEG and all kinds of things. And it's amazing when sleep gets disrupted, no matter how good the food is, how good they're hydrating, if the sleep is disrupted, it sets them up for injury constantly, and it affects their performance. In sports, why is that? Is a huge component of my sleep impacts my testosterone production. And so that affects my, in the clinical space, sleep is super important as well. Over a third of children and adults diagnosed with ADHD, actually a third, okay, that's, 33% of people diagnosed with ADHD have an underlying sleep problem that's going misdiagnosed and is not getting diagnosed correctly, and they're getting misdiagnosed with ADHD when they don't really have it. They have an underlying sleep. Sleep is so, so important. If you were to go 7 to 8 days without sleep, you would become psychotic. You could not function. You would lose touch with reality. If we went 13 days without sleep, you would die. It's just crazy to think about that. I mean, how many illnesses on the planet would you die in 13 days from? Even the most aggressive forms of cancer don't impact us at this level. 13 days without sleep and I'm dying. Wow. And the reason for that is sleep is such an important factor in our energy production. And we'll finish up with this. The number one thing, okay, the number one thing that we're going to look at that is an energy source for us, okay, is number one. You probably guessed it, but it's oxygen. You have got to have oxygen. Think about that for a second. I go without food, I can go without water, go without a little bit of sleep, but how long can you go without oxygen? Not very long. Actually, if we really think about it, if I took oxygen away from you for 4 minutes, you would give up everything that you possess, everything, for one more breath, because you need that oxygen to survive. And after a few minutes, you're going to start to kill brain cells with that oxygen. People don't realize that, get this, 90% of the energy that my power plant is making, 90% of the energy that gets me through the day comes from oxygen. And we focus so much on these little changes in nutrition, which that's important, super important. Hydration, how much water am I drinking in the day? Sleep, we probably don't pay enough attention to, but are we really thinking about how we're taking in oxygen? Well, and that's why these different religious practices that have been around for centuries that focus on breathing are really tapping into something that's actually very scientific, is that we have to stop and breathe in certain ways to optimize our management or how we make energy. Okay, so today, this first lecture, I would kind of say that this is all about making. How do we make the electrical current? Our next lecture is going to be how we manage it. How do we manage the electrical current? We're making it all the time, okay? But we can't use it at a high rate all the time, or we have to take in more resources. And there's a part of our nervous system called the autonomic nervous system, which is super amazing, that allows us to manage the electrical current in an unbelievable way. And I'm super excited to talk to you about that next week. Okay, so it's great having you watch this lecture again. I recommend that you maybe come back to this down the road, and hope you have a great day, and let's learn more about the brain next time.